exploring feature extraction, a machine vision perspective.
Welcome to the Universal Principles podcast. Today, we're diving into feature extraction. It sounds very technical, but it's something we all do every day. We're excited to explore how this principle plays out in the world of machine vision. What can you tell us about this field?
Thanks for having me. Machine vision is all about enabling computers to see and understand images, much like we do. It's used in everything from self-driving cars to medical image analysis. Feature extraction is utterly crucial for this process. It's all about simplifying overwhelming data for efficient processing.
So, feature extraction is about data simplification. Before we get ahead of ourselves, could you walk us through a concrete example of feature extraction in machine vision and how it helps?
Certainly, think about facial recognition. Raw image data is just a massive grid of pixel values. Feature extraction involves identifying key elements like the edges of the eyes, nose, and mouth, reducing the data to essential components that define a face. This makes it easier for the computer to compare and identify individuals. Without it, facial recognition would be virtually impossible.
That makes perfect sense. So, instead of processing every single pixel, the computer focuses on the important parts. Can you give us another example where feature extraction is helpful?
Absolutely. Consider quality control in manufacturing. Imagine a conveyor belt full of widgets. Machine vision systems use feature extraction to identify defects. Instead of analyzing the entire image of each widget, the system might focus on specific features like the size of a hole or the straightness of an edge. This allows for rapid and accurate detection of faulty products.
So it's all about finding what's actually important. It's amazing to see how one core principle can have such broad applicability. It seems like data science might use similar principles. Is there a similarity that comes to mind?
Definitely, a related principle is dimensionality reduction in data science. Just like feature extraction, dimensionality reduction aims to simplify data by reducing the number of variables. In machine learning, this can involve selecting the most relevant features from a dataset, discarding irrelevant ones, improving model performance, and reducing computational cost. It's feature extraction's close cousin.
That's a great connection. So how can our listeners apply feature extraction in their own lives, even if they're not working with computers or images?
Here are a few quick tips. First, when problem solving, identify the core issue rather than getting lost in details. Second, when learning something new, focus on the fundamental concepts before diving into advanced topics. Finally, when communicating, extract the key message you want to convey and structure your thoughts accordingly.
Those are some great takeaways. It sounds like feature extraction is about being efficient and effective in how we process information, no matter the context. Any final thoughts?
Exactly. Feature extraction emphasizes that focusing on what truly matters yields more insightful results. Understanding this principle empowers you to simplify complexity, identify patterns, and make informed decisions, regardless of the field.
Thanks for sharing your expertise, and thank you for joining us on Universal Principles. Be sure to tune in next time as we explore another fascinating principle that shapes our world.